Have you ever wondered what made Albert Einstein, the man behind the theory of relativity, truly exceptional? This question has puzzled many for generations. The intriguing enigma that is Einstein, with his trademark unkempt hair and expressive eyes, has always been a beacon, captivating the minds of scientists and non-scientists alike. His life and work, imbued with a combination of brilliance, eccentricity, and unwavering commitment to his craft, have given rise to stories and theories that have shaped our understanding of the universe. Yet behind the scientific genius was an extraordinary individual with a fascinating journey. Our aim in this video is to delve into that journey to understand the man behind the science, the struggles and triumphs, the moments of eureka, and the quiet reflections. From his early years to his revolutionary theories and later life achievements, we'll embark on a voyage through time. Join us as we unravel the life of one of the most influential scientists of the 20th century. Born on March 14, 1879, in Ulm, Germany, young Albert Einstein's curiosity was sparked early. As a child, he was inquisitive, always questioning how the world worked. His father, Hermann Einstein, and mother, Pauline Koch, nurtured this curiosity, with his father introducing him to the wonders of science and engineering through a simple pocket compass. Albert's fascination with the unseen forces that move the needle was the first spark of his lifelong passion for unraveling the mysteries of the universe. However, his journey wasn't without obstacles. Despite his keen interest in the sciences, Albert struggled with the rigid educational structure of his time. His non-conformist nature often clashed with the traditional teaching methods, leading him to leave school at the age of 15. Yet this didn't dampen his thirst for knowledge. He continued to study on his own, focusing on mathematics and physics, subjects that deeply intrigued him. His self-guided education eventually led him to the Swiss Federal Polytechnic in Zurich, where he enrolled in a 4-year physics and mathematics teaching diploma program. It was a place where his ideas could flourish, away from the constraints of traditional education. During his time at the Polytechnic, Albert began to formulate the concepts that would eventually lead to his revolutionary theories. He was a diligent student, immersing himself in complex equations and scientific theories. His professors, though initially skeptical of his unconventional methods, soon recognized his potential. Yet, even as he excelled academically, Albert remained an outsider, preferring solitary study to socializing with his peers. He was a dreamer, often lost in his own thoughts, contemplating the mysteries of time and space. Despite his solitary nature, he found companionship in his future wife, Mileva Maric, a fellow student at the Polytechnic. Their shared passion for science created a bond that would endure the trials of their personal and professional lives. Einstein's early years set the stage for a career that would forever change our understanding of the universe. In 1905, Einstein introduced the world to his revolutionary theory. This was a year that would go down in history as Einstein's miracle year. Over the course of 12 months, this young patent clerk, not yet recognized in the scientific community, published 4 groundbreaking papers that would forever change our understanding of the universe. The first of these papers addressed the photoelectric effect, a phenomenon that would later form the foundation for quantum mechanics. He proposed that light was composed of individual packets of energy, which he called quanta, or photons, contradicting the prevailing wave theory of light. The second paper introduced a new way of looking at the erratic motion of particles suspended in a fluid, a phenomenon known as Brownian motion. His mathematical explanation provided concrete evidence for the existence of atoms and molecules, which were until then just theoretical constructs. But it was his third paper that truly shook the scientific world. Here, Einstein proposed his special theory of relativity. He suggested that space and time were not separate entities as previously thought, but interconnected in a 4-dimensional continuum known as space-time. The fourth paper, a direct consequence of the special theory of relativity, gave the world the most famous equation in physics, E equals mc squared. This simple equation encapsulated a profound truth. Energy and mass were interchangeable. It was a concept that laid the groundwork for the development of nuclear energy and the atomic bomb. Einstein's revolutionary theory redefined the way we understood time, space, and gravity. His insights laid the foundation for much of modern physics and continue to inspire scientists and researchers worldwide. His miracle year was indeed a turning point in our understanding of the cosmos. Having left a significant mark on theoretical physics, Einstein's later life was just as eventful. In the early 30s, as the shadow of fascism loomed over Europe, Einstein made a profound decision. He traded the cobblestone streets of Berlin for the bustling avenues of the United States. A new chapter of his life unfolded in Princeton, New Jersey, where he accepted a position at the Institute for Advanced Study. Here, Einstein continued to explore the mysteries of the universe, generating theories and concepts that would further enrich our understanding of the cosmos. Amidst his academic pursuits, Einstein's brilliance found its way into a more tangible, albeit controversial form. His famous equation, E=mc2, became a pivotal element in the development of the atomic bomb. It's important to note, however, that Einstein was a pacifist, deeply shaken by the destructive potential of his theoretical work. When he penned a letter to President Roosevelt warning of Nazi Germany's nuclear ambitions, he was driven by a desire to protect, not to harm. Einstein's influence wasn't confined to the chalkboards and lecture halls of Princeton or the secret labs of the Manhattan Project. He was an outspoken advocate for civil rights, using his platform to challenge racial segregation and discrimination. When African-American singer Marian Anderson was denied a hotel room because of her race, it was Einstein who offered her shelter in his own home. He aligned himself with the National Association for the Advancement of Colored People, lending his voice to the fight for equality. Einstein's later life was a testament to his belief that science should serve humanity, not just in the abstract realm of theoretical physics, but in the everyday struggle for peace and justice. From the lecture halls of Princeton to the front lines of the civil rights movement, Einstein used his influence to champion the causes he believed in. Einstein's influence extended beyond the realm of science, reflecting his deep commitment to peace and human rights. Albert Einstein passed away on April 18, 1955, but his legacy lives on. His name has become synonymous with genius, and his theories continue to shape the way we understand the universe. From the smallest particles to the largest galaxies, Einstein's fingerprints are everywhere in modern science. Let's take a look at how his work continues to impact us today. First, there's quantum mechanics. Einstein was instrumental in the early development of this field. His work on the photoelectric effect, for which he won a Nobel Prize, laid the foundation for quantum theory. Today, quantum mechanics is at the heart of technologies from lasers to computer chips, and it's even leading us into the exciting new territory of quantum computing. Next, we have the GPS technology that's become an essential part of our everyday lives. Whether you're navigating city streets or hiking in the wilderness, you're relying on Einstein's theory of relativity. Without accounting for the time dilation effects predicted by his theory, the precise timing required for GPS would be off, leading to inaccuracies in positioning. So, next time you're finding your way with your smartphone, thank Einstein for the assist. And then there's the discovery of black holes, those mysterious cosmic entities that captivate our imaginations. Einstein's general theory of relativity predicted their existence long before we had the technology to detect them. Today, black hole research is pushing the boundaries of our knowledge, with revelations like the first ever image of a black hole, captured in 2019. Einstein's influence extends beyond science, too. His philosophical reflections on the nature of reality and the human condition continue to inspire thinkers across disciplines. His calls for peace and humanitarianism resonate as strongly today as they did in his own turbulent times. Einstein's life and work continue to inspire and influence, proving that his theories were not just relative but revolutionary. His trailblazing spirit and relentless curiosity have left us with a legacy that reaches far into the future, reminding us that the universe is full of mysteries waiting to be unraveled.